Now let's revisit the relationship between molecular formula and empirical formula. We look at these three different compounds, which are carbohydrates. They're actually simple sugars. And we notice that each one of them has the same empirical formula, even though the molecular formula is clearly different. So even though they all have the same empirical formula, how are they different? Well, the molecular formula, of course, is different, and so therefore their molar mass is going to be different. This molecule down here has twice the numbers of carbon, hydrogen, and oxygen than this molecule of glyceraldehyde, so its molar mass is going to be twice. We're going to use this relationship between molar mass to help us figure out the relationship between empirical and molecular formula. So we can actually get the molecular formula from the empirical formula. The molecular formula is a multiple of the empirical formula. If we look up here, the molecular formula we get by multiplying each subscript here by 3. We get our molecular formula by multiplying each subscript by 4. We get the molecular formula by multiplying each subscript by 5. And here we get the molecular formula by multiplying each subscript by 6. So the molecular formula is a multiple of the empirical formula. To get the molecular formula, you have to know the empirical formula and the molar mass of the compound. So far, we've just been calculating the empirical formula. To get the molecular formula, you also need the molar mass, and you'll have one additional calculation to do. What you do is you take the molar mass of the actual formula of the chemical, you divide it by the molar mass of the empirical formula, and you will get a whole number. You use this whole number to multiply the subscripts in the empirical formula, and you'll get the molecular formula. So let's look at how this works. Okay, so we're asked to determine the molecular formula of this compound, cadenine, if it has a molar mass of 204 grams and empirical formula of C5H8. So we have the two bits of information that we need. We need the molar mass and we need the empirical formula. So if we look back here at our formula to calculate it, we need the molar mass of the real formula, which is given, and then we need the molar mass of the empirical formula. So we're going to calculate that. Here's our empirical formula, and to calculate it, we multiply the molar mass of carbon, which is 12 by 5, to get 60.05. It's actually 12.01. And then we multiply the molar mass of hydrogen by 8. Now, for some reason in these slides, the author is taking the sig figs of hydrogen one beyond what's in your textbook. So if you're just using your textbook, it should come up to 8.08. And when you add these two values together with incorrect significant figures, you're going to get 68.11 grams per mole as the molar mass of the empirical formula. So now we have the molar mass of the actual chemical and the molar mass of our empirical formula. We divide the molar mass of our real chemical by the molar mass of our empirical formula, and we'll get a whole number. Round to the nearest whole number. You may get something like 2.99 or 3.01. Round to the nearest whole number. This will not be any halves or quarters or thirds here. It will always be near a whole number. This is the factor that you're going to multiply the subscripts in the empirical formula. So the actual molecular formula is C15H24. Here's our empirical formula, and we multiply each subscript by 3. 3 times 5, 15, 3 times 8, 24. And if we double check the molar mass of this, we will find it is 204. So go ahead and pause the slide and see if you can figure out this problem. Benzopyrene has a molar mass of 252 grams and an empirical formula of C5H3. what is its molecular formula? And they're being kind here and giving you the molar mass of these two elements. So the first thing we want to do is calculate the molar mass of our empirical formula, C5H3. 5 times 12.01, 60.05, 3 times 1.01, 3.03. Here's the molar mass of our empirical formula. We divide that into the molar mass of our actual chemical, and we get 4. Now, I didn't point this out earlier, but notice our units cancel out. The units for molar mass are grams per mole, and so they cancel out, and we get a whole number 4 here. We take this 4, we multiply it by the subscripts, and the correct molecular formula is C20H12. And you can always take the time to double check by recalculating the molar mass of this to see if it matches your given.